Okay, let's talk about 11.2, and this is our introduction to surface area of 3D figures. So this is a tough lesson. It takes a lot of organization and keeping all of your numbers and formulas in order, so that way you don't get messed up, because you can make one little error and then the whole problem is wrong. So it's really important to take your time on this and go slow and make sure you have all the pieces. So, surface area, let's talk about what it's literally the area of the surface of these 3D figures. And so you find the area of each face, or it's also called a side, if you think of it probably as a side, but the mathematical term is a face. And it says right here, faces are the surfaces you can touch. So we have to find the area of each face and then add them all up. Okay, so let's get into a problem. So start with a regular rectangular prism. Okay, so let's talk about this. Are there any of the sides that are the same? Any of the faces that are the same? The answer is yes, there's a couple of them. So let's start with the top and the bottom faces are identical, right? They're both rectangles, so I'm going to draw a rectangle. Actually, let's label them. Top and bottom. Okay, and they are rectangles. What are the dimensions of those rectangles? Well, it looks like they are a 4 by 10. Okay, not too bad so far. All right, let me highlight that so I kind of have it for later. And then let's do the left and the right side. This is how I do it. I label it all out. Left and the right side. That would be right here. There's one. Here's the right side. So those are also rectangles. And so they are 6 by 4s. Cool. And then the last would be what? Front and back is what I'm going to call it. Okay, so this might get a little crazy. That's okay. So it's this side. And then I'm not going to shade the back because it's kind of hard to see because they're overlapping. So front and back is also a rectangle that looks like that is a 10 by 6. Okay, so now let's find the area of each one of these pieces. So top and bottom, I'm going to write the base times height. Don't complain, it took me half a second, just do it. So base times height, 4 times 10, that gives you 40. Cool? The left and right side, write base times height again. Again, it took you half a second, just do it. 6 times 4, that's 24. And then the front and back, base times height, 6 times 10, that gives you 60. All right, so now let's do the actual surface area. So how would I add these up? Well, it's a little tricky on this one. It's not 40 plus 24 plus 60, because if you remember, there's two sides that are 40, because the top and the bottom. There's two sides that are 24 and two sides that are 60. So there's a few different ways to write it. I'm just going to write it like this. Is 2 times 40 plus 2 times 24 plus 2 times 60. That's what makes sense to me. You could write 40 plus 40 plus 24 plus 24 plus 60 if you would like. I'm just not going to. Okay, when I stick that on my calculator, I get 248. Now let's talk labels. This is a 3D figure, right? So some of you may think, oh, it's meters to the third power. And that would be true if we were doing volume, but we are still doing surface area. It's the area of the surface, so it's still flat, a two-dimensional amount, so it would be meters squared still. Okay, and that is how you just did your first surface area problem. All right, this one's a good one. So let's talk about this. So it looks like this is a triangular prism. It has 5 sides. So we've got the front and the back, which are both triangles, right triangles. So I'll just write a little sign up here. 2 of these, right? Okay, now looks like, let's talk about, we'll just go ahead and do this one first. what are you going to call that? The left side? Sure. Looks like that's a rectangle. Okay, and it looks like it's a 5, and this distance right here, that would be 12. So this would be a 5 by 12. Okay, now let's talk about another one. This bottom side, that looks like a rectangle. Is it a 5 by 12 too? No, it's not. So we got another rectangle that looks like that one is an 8 by 12. All right, and then the last one, why is this not, hold on. Okay, there we go. So the last one would be, this is where it gets fun, I hope you're ready. We've got this piece right here. So that's a rectangle, of course. So draw another rectangle. It looks like it's a 12 by, what is this side right here? We gotta figure that out. Anybody have any ideas? Yeah, there is an idea. So we're gonna have to do they don't give it to us. You're going to have to do one of your favorite things that you've been doing a lot lately to figure out that missing side of that triangle, which is the good old Pythagorean theorem. A squared plus b squared equals c squared. Which side is our c? Well, it's our missing side, so that's one we're trying to find. Okay, and then so I'll put 5 as my A, 8 as my B, it doesn't matter which one. And you get 25 plus 64 equals c squared, which is 89 equals c squared. Square root, so that c is, I think it is 9.4. Yeah, I just checked on my calculator. Okay, so that means that this piece right here is 9.4. So cool, we found that missing part of that rectangle. It's a 9.4 by 12. All right, I think we have all the pieces. Double check. On a triangular prism, there's 5 faces. I have 2 there, 3, 4, 5 sides listed, so let's go. All right, let's do the triangle first. What's your formula? 1/2 base times height. So 1/2 times 8 times 5. I believe that would give you 20. Base times height for this, 12 times 5, which is 60. Base times height again, 8 times 12, which is 96. Base times height, 12 times 9.4 gives you 112.8. All right, looks like we are ready to do the surface area. So surface area. Remember, you have 2 of those triangle sides, so we need to have 2 times 20 plus 1 side that's 60 plus 1 face that's 96 plus 1 face that is 112.8. When you stick that in your calculator, you get 308.8. We're still talking about surface area, so that would be feet squared. All right, last one of these triangular prisms. This one's tricky, but it's okay. All right, so what do you see? I see the 2 triangle faces. Looks like they're the same, so 2 of those, right? And it looks like this side right here is 6. Okay, so just keep that in mind. So on this triangle, we got a 6, 6, and 6. Okay, and so then we'll just do the bottom side first. So here's the bottom side. That's a rectangle, and it is an 8 by 6. Cool, let's do the, we'll call it the left side right here. That would be, looks like an 8 by 6 as well. Cool, we have 2 of those. And then this front, or this right side right there, that would be an 8 by 6. So there's 3 of those. Okay, double check. There's 5 faces. Do we have 5 faces listed? Yes. Okay, so let's do it. Sorry, I'm gonna erase this. Okay, so let's just get the rectangles out of the way. That's the easiest part. Let's do it. Base times height, 8 times 6, 48, done. Cool. Now here's where it gets fun. We're gonna have to worry about this triangle. So for your formula for a triangle, you need 1/2 base times height. So I know my base is 6, right? But they do not give us the height. This is the height right here. Okay, so we need to find that amount. And there's a few different ways to look at it, but first of all, what type of triangle is that whole thing? Well, that is an equilateral because all the sides are the same. So if you remember back from first semester, equilaterals have 60-degree angles. All of them are 60. So this is 60, this is 60, and this up here is 60 as well, but I'm going to erase that because I'm going to change it in a second. So all three of those angles in that triangle are 60. Okay, so what happens if I cut this triangle in half and I just have this? What does it turn into? Oh, it's your favorite, a 30, 60, 90. So 30, 60, 90, look at your cheat sheet. So which side is your X side? I'll change colors on this. So the short side's your X. The hypotenuse is the 2 times X. And the height is X times square root of 3. Cool. So if 6 is my 2x, 2 times what gives me 6? 3. Therefore, x must equal, let's switch colors, x must equal 3, right? Cool. So then what would the height be? Well, it would be 3 times square root 3, because it's x times square root 3. All right, so let's double check. Our base. Some people on this, when you start doing your triangle, you may think your base is 3. It's not. It's the whole base of the whole triangle. We just split it in half to find that height. So it's still 6. And then times the height, which is 3 square root 3. All right, so let's do some math. Okay, I'm going to type that in my calculator. And I have 15.6. All right, we're ready to do the surface area. So how many sides or how many faces are 15.6? 2 of them, so it's going to be 2 times 15.6. Plus there's 3 faces that are 48. And then type that in your calculator. And you get 175.2 inches squared. All right, so just know whenever you have some of these prisms, sometimes you're going to have to use the Pythagorean theorem. Sometimes you're going to have to use the 30-60, maybe 45-90s. So just be aware that sometimes it takes a little investigating to do these problems. All right, let's move on to a cylinder. So when you lay out, I wish if you were in class, I have a net of a cylinder. So a cylinder net, when you unroll it, looks something like this, right? If you were to unroll a soda can, that's what it would look like. Okay, so it's really one rectangle and 2 circles, okay, every single cylinder. So let's do this. So here's our first one. We're gonna have to find the area of all those 3 pieces. So we have 2 circles. So 2 circles, what I love about circles is the only thing you need is the radius, and they give it to you. The radius is 4. Okay, and 1 rectangle. I know the height of my cylinder is 5, so this side must be 5. Okay, so now here's where the fun part begins. I need to find out what this piece is right here, or if you want to look at it up here on this net, that one right there. That's what I'm trying to figure out. Anybody have any ideas? If you were in class, I would fold it back up and show you. That red line is actually the circumference of the circle. So it's kind of cool. It folds back up and it is the circumference of a circle. So that red line would be equal to the circumference of the circle, and our circumference formula with radius is 2 pi r. So 2 times pi times my radius, which is 4. So this distance in red, I want you to leave it in terms of pi. For this one would be 8 pi. Cool. So we're ready to do this. let's do our circle. Pi r squared is my formula for area of a circle. Pi times 4 squared, which gives me 16 pi. Cool, I'm gonna leave it there. Base times height for this rectangle. So 5 times 8 pi, that would give you 40 pi. All right, let's do the surface area. So we have 2 of those sides that are 16 pi plus 1 side that is 40 pi. And when you do this, I want you to leave it in terms of pi. So you're gonna type everything in your calculator except for the pi button. So don't do that. Okay, so 2 times 16 plus 40, I believe that gives you 72. So our answer is 72, and don't forget to leave the pi with it in your answer. So 72 pi, and my label would be meters squared. Cool. All right, I'm only gonna do one more of these. So again, I have 2 circles. So 2 of these and 1 rectangle. Okay, so the radius of my circle, these are bigger numbers, is 16. The height of my cylinder is 25, so that's gonna be right here. To find that other piece of the rectangle, you still need to use the circumference, 2 pi r. So 2 times pi times 16 would give you 32 pi. Cool. Let's do the areas now. So pi r squared for a circle. So pi times 16 squared gives you 256 pi. And then this one, 32 pi times 25 gives you 800 pi. All right, so now for surface area, we have 2 sides that are 256 pi plus 1 face that is 800 pi. Type that in your calculator without the pi's, and you get 1,312 pi. And then, oh, don't forget my label, I almost did. Inches squared would be your label. Okay, that is it for 11.2. Thanks for watching and have a great rest of your day.